In this tech talk, I'm going to show you how you can accelerate a site based on Nuxt.js and Vue by adding the MoveWeb XDN and leveraging the XDN's ability to do prefetching to speed up page transitions on your site. So first, let's start with an example site that I've built for this demonstration on Nuxt.js, not yet running on the XDN. So I'll run it by doing npm run dev. And fire it up here. I love how Nuxt does this. This is really cool. Okay, so I built a little blog app. It's just basically two screens. It's an index page that lists entries. As you can see, it's all just lorem ipsum, and it lists, you know, a little bit over a screen height worth of entries, and then you can click on each entry and then get the full blog post like so. And so you can see it's a fairly slow site. In fact, let me load this up in an incognito window here. Make the test a little bit more stable. So you can see, like, as I click here, there's a few second delay. This is actually using a mock API that is purposefully slow to simulate what we often see in the wild, which is a slow API and how that can drag down even a well-built site on a modern framework. And so what I'm going to show you is how you could take this Nuxt.js app, add the MoveWeb XDN, add prefetching, and speed up the slow navigation between pages. So the way that we would start, and I should mention that this is all listed on developer.moveweb.com under Nuxt.js here, is first you would install the XDN CLI globally. So I've already done that. And then in your Nuxt app, you would run XDN init. So actually, let me make sure that I have a clean, I don't think I have a clean node modules here because I may have done this before. So let me rm.rf node modules and then reinstall what was meant to be there. Okay, so now we're back to square zero. What we would do is XDN init. And what that does is it looks at your app, it figures out what framework you're using, and then it installs the relevant XDN libraries to work with that framework. So you can see it's adding a few different ones here. The core, which has the router, the CLI, which is going to have all of our build commands. It installs a version of that locally in the project, which the CLI will always use the local version if present. And then it installs the prefetch library as well as the Nuxt integration library. And then once it gets done with those dev dependencies, we'll see it install the Vue library as well. It also installs Nuxt Start. Nuxt Start is a lightweight build of Nuxt meant to be run in production. It's much smaller just in terms of file size. And so that helps Nuxt run better in a serverless context. And so the XDN is essentially a serverless cloud for running server-side rendered apps. So this helps keep those serverless functions as small as possible. So You can see it added some commands to our package JSON. We can start the app using XDN start. We can build a production version of the app using XDN build, and we can deploy to the XDN by doing XDN deploy. And it also added some resources. So a routes.js file, which is our XDN router, a service worker directory containing our basic implementation of a service worker that'll help us with prefetching, and then an XDN config file, which has all of the configurations for deploying your app on the XDN. So let's start by looking at the routes file. So the routes file sets up a route for the service worker, which is going to get built automatically when we build our Nuxt app. And then it uses a middleware called Nuxt routes, which basically what that does is it understands the structure of a Nuxt.js application and all of the standard like directory file locations. So like pages, for example, static, and it creates routes in the XDN for those locations. You can add additional routes too, as we'll see. But if I were to run this app right now, basically it would still have all the same pages, but it would just be running behind the XDN router. So in fact, I can do that by just doing XDN run. So this, again, builds the Nuxt app in development mode. And it starts up the MoveWeb XDN in development mode on port 3000. So if I run that guy here, it's the same, basic app there. So now let's add some caching. Let's go to our incognito window here. So if we go here and go to the home page, I'll just refresh some on the latest version of the app. And we look at what happens when we navigate to one of these posts. We can see it's going to /API /posts too. So, and it's actually doing this on a third-party API. So first thing we want to do in order to be able to cache this API is proxy it through the XDN. So we're going to add it as a backend in our XDN config. So let's do that by opening up xdnconfig.js, and I'm going to copy over a little snippet that I have prepared. We're going to create a backend called API, and we're going to point it to that same host name that we were requesting from in our API calls. Then we're going to set up a route where we proxy that path, which was /API to that backend. So we can do that in the routes.js file. Let's grab this guy here. So I've added a get route for everything under /API. This captures any number of path tokens. And then we're going to do a few things with that route. We're going to remove any set cookie headers that come from the API. That will ensure that we'll be able to cache the responses, because the XDN never caches responses with personalized content like set cookies. So we just remove that. Then we're going to declare this as a cacheable route. So we're going to say we're going to cache it in the browser using the service worker for an hour, and we're going to cache it at edge for 24 hours. And then ultimately we're going to proxy the request to the API backend. So this name here corresponds to this name here in our XDN config. And so we also want to do a bit more caching as well. These pages are all server-side rendered. And so server-side rendering is a expensive operation, and you want to make sure that you're caching the result of that whenever possible. So there's two main pages in our app. There's the index, and then there's the /posts. And so let's cache both of those. So the way that we would do that is we add routes to our router, and we just say cache those paths. So let me create a cache config specifically for HTML. You can see I'm referencing here. So this is an example of how we can reuse cache configs between different routes. And so for both the home page and for each post, we're going to cache using this config. And this is preventing caching in the browser using the HTTP cache, and then caching at edge for 24 hours. So the reason that we like to prevent in-browser caching of SSR is that if the app were to change, like a new release be pushed out during the user's browsing session, then that might mean that some of the scripts needed for that app are no longer available, because Nuxt.js and many other frameworks adds hashes to those scripts. And so they might see an error if they were browsing, during deployment. And so, or if they came back to an app that was cached locally after a deployment. And so we always prevent the browser from caching the server-side rendered response, but we just cache it at edge. So it still loads very, very quickly, just because our edge network has very extensive list of pops and is very fast. But we prevent those kind of errors due to cached HTML in the browser. Okay, so to summarize what we've done here, we've added routes for the 2 server-side rendered pages, and then we've added a single route to cache and proxy the API requests. And so now we need to go, I think, into our 2 pages and make sure that we're properly requesting from the right domain. So it's using this API host variable to request from the API. And so let me go and change that guy from this third party to it just should be localhost. So take this guy here and just change that there. And then let me show you what's in the Nuxt config as well, as far as fetching from the API. So I think we have to, for anything that's localhost, since we're using Nuxt HTTP, it's a little bit of a quirky library. We need to add a special config to make it be able to request from the same origin without having to explicitly declare that origin. So that's this public runtime config specifically for Nuxt HTTP. While we're in here, you can see that as part of the initialization process, actually, no, there's one module we have to add here on our own, which is the XDN Nuxt module. So what this guy does is it adds the service worker to the build config. So that'll get built every time we start up our application or we do a production build. And then it adds code to the page to inject that service worker into the browser so that it's actually used. So we just install that module there. Okay, so I think if I've done everything right, what I should see is if I run with XDN run, and this time I'm going to add a flag --cache. So this is going to turn on caching in development to simulate the way that the edge would cache responses based on our router in production. So you can see it tells you when it starts up that caching is enabled. Okay, so now let me go back to my incognito window here, and let's just like clear out the cache so we know we have like a new session with no old service worker or anything, or nothing cached, and we can see what happens when we start up here. Okay, so it went and installed a service worker. That service worker is not really doing a whole lot yet. We should see it actually cache the API responses when we navigate between pages. So for example, if I navigate here, we'll see that cached here. And again, that caching is happening because we have this directive in our API route that says we're caching in the browser for an hour. And we should also see in the console output here whether individual requests are, the caching status of those individual requests. So for example, you see that some of the things here could not be cached. That's because the Nuxt XDN integration in development prevents caching of JavaScript assets. So it just makes sure that you're not going to get stale assets while you're trying to change things in development. You can see that it cached the call to API posts. So it wasn't in the cache yet, but it added it to the cache. And then there were a couple of duplicate requests as the browser like refreshed the page to some assets that are now cache hits, like the service worker and the cache manifest. And you can see that it cached API/post/1. So if I actually remove this guy from my browser cache, so I would request it again, what you would see, just clear this so you can see it clearly. If I go here, you can see that it was a hit. And you also notice that that was pretty fast. It didn't have that 1 or 2 second delay built in anymore because now it's being cached by the XDN locally in development mode. So now we've got caching set up. Let's go and set up prefetching so that we can really speed up page transitions. So the idea behind prefetching is to get as much of the content that the user is likely to see down into the browser, into the cache before the user ever needs it, so that when they do need it, it's just there immediately. So the XDN makes it easy to prefetch all of the visible links on a page. So you can imagine loading this page, having it prefetch everything above the fold here, and then as I scroll down, prefetching additional links. And so that way, if a user clicks on any of those, that page transition will be instant. And the way that it does the prefetching is quite intelligent. It does it with the lowest possible network priority. There's a way that you can inform the browser that a request is very low priority so that if any other more important requests came in, those requests take precedent. They essentially pause the lower priority request, jump in front, and then when they're finished, then the queue opens up for lower priority requests again. So higher priority requests would be like navigation, images, anything like in response to the user. In a sense, anything other than these prefetch requests. So let's go ahead and add prefetching. So what I'm going to do is go to the index page. This is the code for this page right here. And we have to add a prefetch component around the link that we render for each post. So you can see we have our main loop here where we're looping through the posts, and we have our link to each post here. So what I'm going to do is I'm going to add a prefetch component from XDN Nuxt here. It's actually XDN view, so it's not particularly tied to Nuxt, but just tied to view in general. So add this guy in, and then I need to import this component from XDN view, so I can do that down in my script here. And then I need to list that as a component in our export. So that's this here. So now what we should see is if I refresh this guy, let's clear my cache first so we can see it prefetching. We go to the network and then refresh. I did not see it prefetch. Why is that? prefetch here. Let's try it again. Maybe the service worker was not installed yet. Let's see, application service workers there. Let's just kill this window. Trying to install. Yeah, I never know what this guy means. Unknown error when fetching the script. Okay, let me just restart the XDN. Maybe there was an issue with the build there. That could be. In development mode, we actually just added support for service workers in development mode, so there might be an issue with rebuilding like that. So let's just restart. That, and then refresh. Okay, there we go. You can see the service worker loaded. So let's show you what happened. You might think that red is bad, but not necessarily. Red in this case is actually a good thing. So what it attempted to do is prefetch all of the links on the page. So like the first, I guess, 6 links. And they all return the status code 412. Prefetching, as you can see, can create quite a bit of extra traffic. And so if we didn't do something to mitigate that, that could really drown that backend API in a lot of extra requests. Instead of getting 1 request for this page, it's now getting at least 7 requests for the page. And probably more if you had a bigger screen. So the XDN shields the backend from all that extra traffic by only serving prefetch requests from the cache. And so since I just restarted my XDN server, nothing was in the cache yet. So if I navigate to some of these pages, then it's going to make requests to those API endpoints that aren't prefetches, and that's going to start populating the cache. So you can imagine in a real world scenario, you've got the internet and all the users out there banging away at your app. They're navigating through the app and they're kind of organically populating the cache so that prefetching becomes more and more effective with every second or minute that passes after the cache is cleared. So I'm going to simulate that now by just going to a few of these URLs. You can see that one was slow because it wasn't even in the XDN cache. I'll go here, again, slow because it's not in the XDN cache, and then I'll do the third one as well. So now you'll actually see all of these guys in the prefetch cache. So going back is very fast. But let's say now that I'm a different user coming in. Somebody that hasn't been to the app before and hasn't been to any of these pages. So I'll clear the cache to simulate that. You can see down there's nothing in the cache storage. I'll go to the network, clear this guy out, and let's refresh and see what happens for a new user. So I'll refresh that there, and you'll see some of the pages now were able to be prefetched. The first 3 links that other user clicked on, 1, 2, and 3, were able to be prefetched and are now in the cache. You can see that here. So if I click on any of the first 3 links, that navigation will be much faster than it was in the case of the user that came and couldn't get prefetching. So basically instant and not having to wait for that slow API. So that's an example of how you can add the XDN to a Nuxt.js app and speed up your app quite a bit through this caching and then prefetching. So in summary, kind of what we did was we put the XDN in front of the API. We did that by adding a backend to our XDN config, and then adding a route in front of that API to proxy it to the backend and add caching. And then we also added caching to the server-side rendering to make that very fast as well. And then we changed the code in our app to, instead of making a call to a third-party API, now it's making a call to the same origin that the app is loaded from, so that it goes through the XDN and it utilizes this caching. And then finally, we added prefetching to our index page by adding this prefetch component around all of the links. And what that does is when the page loads, it'll prefetch all the visible links on the page, put them in the service worker cache in the browser, so that when you navigate between pages, it's a very instantaneous navigation and giving your users, the fastest possible shopping or browsing experience. And so with that, I'll open it up to any questions. And folks can speak now. You don't have to write your questions in chat. Or maybe there's no questions. Okay, well, then I guess there's no questions. So Ishan, any last words before we drop?
How ominous. No, other than thank you, Mark. It's great to have a Nuxt version of the talk you gave earlier for Next. So thank you for that.
Awesome. And just a reminder, as I said before, everything I did here is all documented in our Nuxt.js guide here on developer.moveweb.com. So if you just go here, you can set up your app using the XDN in front of Nuxt. So thank you, everybody, and see you again next time. Bye.